Today is kind of the first day where I'm going over some material that I've touched on before, but I'm going to go over it in a little different capacity. Um, but we have been going through kind of the science practices section of the GED. So for this week and possibly part of next week, I won't be going over any particular subject matter per se, just talking about kind of the types of questions you might see on the test, some strategies to go over when we're taking the test, and just basically what to expect in terms of styles of questions, types of content you might need to know, and not so much focusing on life sciences, physical sciences, earth science. Okay. So, with that said, today we're going to talk about the scientific method a little bit, which, like I said, I believe is something I've gone over since we started these video classes, but I'm going to pull some new material and do things a little bit differently, so this won't be an exact redo of any classes I've had before. So, when we talk about the scientific method is essentially how we answer questions in a scientific way. Okay? If we are asked a question as scientists, and I know we're not scientists, but pretending we are, right? If we're asked a question, we don't just immediately jump to an answer, right? If we're answering a question scientifically, we have to kind of go through a process or a series of steps in order to get to an answer that is logical, true, or as true as we could hope, and supported by information, right? So the book defines the scientific method as a set of techniques that scientists use to investigate observable facts and occurrences and to acquire new knowledge. All right. I just think of it like, how do we answer questions in science, right? And in order to answer questions in science, we've kind of got to follow these steps, right? And I'm going to just list them off really quickly, and then I'm going to pull up my PowerPoint and show them a little bit more in detail. So, according to the GED book, right, the steps are: 1, observe a phenomenon and formulate a question. The scientific method starts with a question about something that you can observe. Formulate the question about something that you can measure. I'll explain all this after. 2, collect data. Collect data about the phenomenon you are studying. Scientific study is founded on data or observable facts which are used to describe a phenomenon. 3, form a hypothesis. Hypothesis is an educated guess about the answer to the question. 4, test the hypothesis through experiment. 5, draw a conclusion. Right, so that's kind of the scientific method broken down in pretty basic terms. This visual aid kind of shows it a little more clearly, I think. So I'm going to pull this up and talk about this just briefly, and then we will get to some practice questions. When I talked about the scientific method, a couple months ago, I focused more on this PowerPoint and less on the practice questions, and this go around I want to make sure I hit some of the practice questions that deal with the scientific method. You will definitely see the scientific method pop up in some way, shape, or form on the GED. That much I'm certain. You might see it in the short answer section of the test, where I know sometimes they ask you to build an experiment, and you kind of have to show your knowledge of how to best do that. And you might get some questions in the just multiple choice section. But again, here is the scientific method laid out graphically as opposed to just in words, right? So I'll do my best to not spend too much time on this, but the scientific method first starts with a question, right? We have to have a question in order to come up with an answer, obviously, right? So a lot of people think that the first thing you do after you have a question is you come up with your guess or what you think the answer to the question is. But even before you do that, a good scientist would say, before I make any guesses as to what the answer might be, first I want to do some research, right? So the first step really is doing background research, looking into what information is already out there, right? And then once you've gathered some information, that might influence your hypothesis, which is a fancy word for a guess, right? And so they call it an educated guess because background research comes first, then the hypothesis, right? If there was no background research, the hypothesis would just be a guess. But because you've done background research and you've looked into other studies that have been done, or you've found other information that's pertinent to your question, you can say, based on these facts that I've found and based on these studies that have been done, I think this is going to be the answer to the question. So then you formulate your hypothesis. A hypothesis also, and it's oversimplifying it to say it's always this way, but along with being defined as an educated guess, a lot of people like to think of a hypothesis as an if, then, because statement. In other words, if this is the question, then I predict this will be the answer because of these reasons, right? Simple enough. Okay, so once we have our hypothesis in place, or what we think is going to be the answer to our question, then we have to put that hypothesis to the test. And so this little cycle here is basically set up to make sure that we come up with a valid test, right? So test with an experiment, but we have to make sure we set up a good experiment. If we come across problems with our experiment, or we're not thinking of, or we don't take this into consideration or that, right? We have to address that before we can accurately run our test, right? Once our procedure is working, then we can analyze our data and draw a conclusion based on that information. And then one of two things happens. Either the data and the conclusion align with what our guess was, or if it doesn't, then we go back and we can create a new hypothesis that aligns with the data that we found and retest it again and make sure it's right before we communicate our results or come up with our answer. Okay, that makes sense? So that's the scientific method in a nutshell. So let me back up and go back to our practice question page. And again, stop me if you have any questions along the way. I just want to go back, since I didn't read through these steps 4 and 5 here, and talk a little bit more about them. So remember that fourth step is creating an experiment. And so it says your experiment should be a fair test of the hypothesis. In other words, not biased towards, not creating a test that you think is going to produce the result you want, right? You want to produce a neutral experiment without any as much as possible. You may need to adjust the experiment. You would do so by changing only one factor at a time while controlling other factors. We'll get into this when we talk about independent and dependent variables, right? But basically, if we're testing something, we don't want to have lots of other things that might be impacted. In other words, we want to isolate what we're testing so that when we come up with an answer, we know what has impacted that one factor, right? So we're trying to control as many things as possible and make our results as accurate as possible. And then it also says you should repeat the experiment to make sure the first results are valid. So one thing when we're talking about scientific method or experiments or science in general, right? One thing that makes data more reliable or more valid in this case is sample size, right? If we do something once and produce a result, that's great. But if we can produce that same thing 100 times, that experiment is going to be, or that result is going to be much more valid. Because we can say we ran the same experiment 100 times and we produced the same result every time. That's pretty significant. Whereas if we ran it one time, that's not as important, right? It's like when we're taking a survey. If I was to survey 3 people on whatever my topic is, my results are going to be pretty sporadic and might not reflect what people really think about what I'm surveying people, right? But if I survey 1,000 people, 10,000, 100,000, or 1,000,000, right? As I go up, the bigger my sample size, the more accurate my results are going to be, because I have a bigger pool of information to draw on, right? And then the last stage says drawing a conclusion about the hypothesis. When your experiment is complete, you may conclude that your hypothesis was supported or that it wasn't, in which case you may formulate a new hypothesis. And we're going to talk about conclusions probably again tomorrow, so I'm not going to revisit that. So make sure we've got plenty of time to get through these questions. I want to make sure we get started. Okay. So questions 1 through 3 on this page deal with this made-up experiment. Okay, so I'll read through it. If you want to read through it on your own, feel free to just mute me and read through it. And then when we get finished with it, we can back up and go over the questions. But I'll read through it regardless. So it says a majority of teenagers develop acne, but scientists still struggle to explain its cause. It has long been thought that bacteria play a role, although until recently it was assumed that role was purely detrimental. In other words, contributing to acne. However, a team of researchers began to wonder whether different strains of bacteria might impact acne in different ways. The research team studied 49 individuals with acne and 52 individuals without acne, and the researchers collected samples of bacteria from the nasal pores of all those individuals. The researchers found that some combinations of bacterial strains were highly likely to be found in clear-skinned individuals, while other combinations were highly likely to be found in individuals with acne. After carefully analyzing their data, the scientists concluded that while some bacteria combinations likely contribute to acne, other bacterial combinations may actually help to ward it off. Researchers suggested that if further studies confirm these findings, we may want to treat acne by encouraging the growth of helpful bacteria. Okay, so a lot of words, pretty wordy, but the short version of that is some people were studying acne. They thought that bacteria might not only lead to acne, but also maybe lead to clear skin as well. In other words, bacteria might be harmful in terms of acne, and it might be beneficial in terms of preventing acne. To test that, they collected samples of bacteria from people with acne and people without it and examined it. And in the end, they found that there was a commonality between people that had acne and people that didn't in terms of the bacteria. Okay, great. Now, let's look at question 1. So it says, use the boxes below to identify the researchers' independent and dependent variables. So, we haven't talked about this, so let's talk about it. So, and I'll try my best to not get these two things mixed up. So, the way I look at independent and dependent variables is I think about how they relate to the question. So if the question or the I guess in this example, the question was, um, what are what what are the causes of acne? Okay, what leads to acne? And so the dependent variable is what you're directly testing. In other words, what you think is impacting the question. So if the question is, what do we think is contributing to acne? And the dependent variable would be combinations of bacteria, right? That's what they are guessing is leading to acne, okay? Independent variables, and hold on a second, because I want to make sure I'm not getting mixed around here, because for whatever reason, my brain's not operating on all cylinders right now, and I want to make sure I'm not mixing everything up. Give me just 1 second. Let me dig in here, because I didn't know to mix up. Sorry, let me back the train up a little bit. All right, so the dependent variable, like I was saying, is what is being tested, okay? So before I erase what I said about combinations of bacteria and just think of what is this test looking at, okay? The dependent variable is what is being directly tested. And in this case, what is being tested is acne symptoms, okay? In other words, what leads to acne, okay? So I took it a step too far. So the dependent variable here is acne symptoms, and it's dependent because it is directly related to the question, right? I can't change the dependent variable without changing the question. Whereas the independent variable is what we think is impacting the dependent variable. And that can change regardless of the question, right? That might be like, well, we think that diet is the independent variable. Maybe what people are eating is impacting their acne, okay? And we might do a test and find out that that's false. And we can change the independent variable without changing the question, right? The question is still, what leads to acne? What are acne symptoms? And so the independent variable here is what we think is directly relating to whether people have acne or not. Again, the dependent variable is acne symptoms. So what do you think the independent variable is? What do these researchers think is impacting whether people have acne or not? Would the right answer be teenagers, combinations of bacteria, or treatments for acne, right? These researchers believe that combinations of bacteria are what lead to people having acne. So acne symptoms goes here. The independent variable in this example would be combinations of bacteria. Sorry, I got jumbled around. Okay? But hopefully that makes sense. All right. So let's look at a more straightforward question. Number 2. Number 2 just says, what was the researcher's hypothesis? A, combinations of bacteria are a major cause of acne. B, different kinds of bacteria may impact acne differently. C, we may want to change the way we treat acne, treating it by encouraging the growth of beneficial bacteria. Or D, some combinations of bacteria may actually help ward off acne. Which of those is the researcher's hypothesis? In other words, the guess to their question. And remember, their question is, what impacts acne? So what leads to people having acne versus not, right? That's the question. What is their prediction? In other words, what do they guess is going to be the answer to the question? And if we look here in this first paragraph, it says a team of researchers began to wonder whether different strains of bacteria might impact acne in different ways. So they're not directly telling you what the hypothesis is, but it's wrapped up in that last sentence. Okay? So in other words, before they start their experiment, their prediction is that there might be strains of bacteria that impact acne in different ways. In other words, not just negative. So if I was answering number 2, the first thing I'd probably throw out would be C. We may want to change the way we treat acne, treating it by encouraging the growth of beneficial bacteria. That, let me make sure I'm not answering my... Okay. So the reason that C is wrong is because it seems to be something that would be stated after the fact. In other words, something that the researchers something that the researchers might come to after their experiment is over, the realization that they come to. Hypotheses or hypotheses happen before the experiment. So C isn't something that they were necessarily guessing would be the answer to the question. That's more of an afterwards. So I'd throw out C, and I would throw out I'd throw out A. Combinations of bacteria are a major cause of acne. That isn't necessarily what they're guessing is the answer. It says it has long been thought that bacteria play a role, right? It doesn't, the fact that it's a major cause of acne isn't necessarily what they're trying to get at, right? They say we think it's a cause, but we're looking more specifically at can it be a positive as well as a negative, right? So I'd throw out A, and I'd look between B and D. And B and D are pretty similar. They're worded a little bit differently. They're saying a similar thing. B says different kinds of bacteria may impact acne differently. And D says some combination of bacteria may actually help ward off acne. This is a tough one in my eyes. They both seem pretty good, but again, which one best answers the question? And in your, you might think one versus the other is better, but you're trying to figure out which one does the test think is the best, right? Because your personal best answer is unfortunately not important in this situation, right? So the reason that B is correct and that D isn't, some combinations of bacteria may actually help ward off acne. That might be what they're hoping to learn from the experiment, but D is much more of a statement, as in we can, the way it's worded, some bacteria might help ward off acne, whereas B is phrased more open-ended, more as a question. Different kinds of bacteria might or may impact acne differently. It's not saying that it will definitively or that it does. It's just saying we are predicting different kinds of bacteria might impact acne different ways. So B is the better choice. But I could understand why you might pick D as the right answer also. Okay, so let's look at how many minutes. 5 more minutes. Let's look at number 3. Number 3 is the last question that deals with this paragraph. And number 3 deals with not the hypothesis, but the conclusion. In other words, what is the end result of the experiment? What conclusion did the researchers reach based on their data? A, combinations of bacteria are a major cause of acne. Acne sufferers have more types of bacterial strains in their pores than do non-sufferers. C, the way we currently treat acne is misguided. Or D, some combinations of bacteria may actually help ward off acne. All right, So we're looking to see that after the test has been done, what kind of conclusion did the researchers come to based on the results of their experiment? So again, let's look at these and see if we can't, get it down to two. The first one I'd throw out is B. Acne sufferers have more types of bacterial strains in their pores than do non-sufferers. It doesn't say anything in there about more or less bacteria. It just says that people that have acne tend to have different types of bacteria than people without acne. It doesn't say they have more. It just says they have different types. So B, I'd throw out. The other one, again, for similar reasons to why I threw it out last time, A, combinations of bacteria are a major cause of acne. That wasn't what was being tested. B, like I said, that is something that was discussed, but it doesn't say it was a major cause. It just says it is believed to be a cause of acne. There isn't anything in here that states that bacteria is a major cause or a big contributor to acne. So it doesn't answer the question on multiple levels. So throw it out. So look at C and D. C and D are, just like the last question, C and D are close. They're similar, but they are worded different. C says the way we currently treat acne is misguided. D, some combinations of bacteria may actually help ward off acne. So again, they're worded differently, but they're saying similar things. Right? Their conclusion implies, in other words, without saying it directly, it does imply that C is true. That because we don't know much about acne and we don't know much about how bacteria affects acne, we probably are treating acne in a way that isn't as beneficial as it could be. So C is implied, but it's not necessarily the direct conclusion of their results, right? D is much more a direct answer of their question. Some combination of bacteria may actually help ward off acne. That's the conclusion they come to, okay? So hopefully that makes sense. And then the last question here has us mix and match these different things. So let's do this, and then we will call it a day. So I'll go through it quick. It says, suppose you notice your right knee hurts every time you play softball. You suspect that one of the movements involved in playing softball is causing your knee to hurt. You are not sure which movement is the culprit. You decide to do a scientific investigation to find out more. So we're going to match each of the following steps of the scientific method with a phase of your investigation. So, because we're kind of out of time, I'm just going to go through and do these in order. A, form a hypothesis. So our choices are down here. And let's see here. I'm just trying to think of the best way to do this without kind of rushing. I'll read through them very quickly and we'll just plug them in. So our first choice is you make a list of each of the movements involved in softball. In the off season, you plan to perform each movement several times without performing the others. 2, based on the data you collected in your experiment, you think it is likely that stopping suddenly after running a short distance is indeed the cause of your knee pain. 3, based on your experience, you make a guess about which of the movements involved in playing softball puts the greatest stress on your knee. You suspect that it might be stopping suddenly after running a short distance. Or after performing each movement in isolation, record how your knee feels. Let your knee recover between tests of each type. Okay, so we need to find out the hypothesis, the test, the collection of data, and the conclusion. All right, so it gives it away with the word guess, but number 3 is the hypothesis. Based on our experience, we guess which of the movements involved puts the greatest stress on our knee, and we guess that that is stopping suddenly. That's our hypothesis. Next, we design a test for our hypothesis, and that would be this first. making a list of each of the movements involved. In the off season, when they're not playing games, we perform each movement several times without performing the other. So that's the creation of the test. C, the collection of data. That would be number 4 here. After performing each movement, recording how the knee feels. So that's the data collection. We're performing the test and we're recording the results, right? That's C. And finally, D, form a conclusion. 2 says, based on the data you collected in your experiment, you think it is likely that stopping suddenly is indeed the cause of your knee pain, so that would be the conclusion, right? Sorry for going through that very quickly. Hopefully the whole idea of scientific method makes sense. We spent probably more time going into it than we needed, but again, just having a basic sense of how do we get from question to answer, that's all we're looking for. So with that, I will let everyone go, and I will see you back here tomorrow for more science.